Hey ladies and gentlemen, Excel is used a great deal in chemistry and sciences and business classes. Anywhere there's lots of numbers involved and you don't want to have to do all the math by hand with a calculator. So there's really easy ways to use some math functions in Excel beyond addition and subtraction. And we're going to kind of touch on some of those. We're also going to talk about how to drag and repeat a math function over and over again, how to highlight things, how to make graphs, and then some other random functions like how to lock a cell down or averaging and those sorts of things. So let's go to our Excel. So here we have some data that a student collected, and the student obviously had a very poor scale and only went to one decimal place and could only do the volume to two decimal places. But so she has a series of samples. How many samples does she have? Let's see. She's 1, 2, 3, 4, 5, 6 samples. There's a couple ways to do what I just did. Obviously, I just typed them in. Control Z those. Let's try that again. 1, 2, and maybe instead of going down to 6, maybe it goes really far. So one of the key skills in Excel that you have to learn is how to highlight some cells. So the way you highlight cells is you use the left mouse button, you click and drag. When you get to that value, you have to hold down the left mouse button and keep going. So if I highlight these two, Excel sees a pattern, and I'm going to repeat it. And one key thing I kind of skipped there is watch the cursor. Cursor is right now, it's a white plus sign. Get in here, it changes. Look, oh, I can drag things around. Um, but what I want to focus on is when the cursor gets right to the corner, it becomes a black plus sign. And if I drag down while it's a black plus sign, and again, drag means hold the left mouse button in and drag down, then it repeats the pattern. So that was a really long way of filling in these 6 samples. And under normal circumstances, you probably wouldn't do that, something like that, for no, just 6 samples. But as a scientist, maybe as a business person, you may have hundreds of values, and you don't want to be doing that over and over and over again. So let's do our first simple math problem here. We have masses and volumes, and we're calculating densities. So it says right here, density is equal to mass divided by volume. So this cell here, for sample 1, needs to be equal to the mass divided by the volume. So what I've done is I have clicked the equal sign and then picked the first cell by clicking on it with the left mouse button, hit the division sign on the keyboard there, and then clicked the next cell. And so referencing B4, cell B4, cell C4, enter, and wow, that is a lot of decimal places. We will truncate those in just a second. Then we drag down. And again, if I go to the corner, I can drag down, and we'll see what happens. It is taking those two cells and doing it. Or hit escape, these two cells and doing it. It's dragging it down. So we have way too many values in here. Let's highlight the range. We're going to truncate it. Up here we have add decimals, remove less, less. Proper sig figs. We should have 2 sig figs and 2 sig figs. Even this one is 3 versus 2. So it looks like we have an average, we have density between 22 and 23. Obviously it's osmium based off of this chart. But let's do some more things. Let's see, we could take an average, right? So how are we going to do the average? Hit the equal sign. The equal sign allows us to average ranges or sum them up. And right here we have this little function, insert function, and we could take average, okay, and then it is predicting our range. D4 is this one, D10 is that one. I actually only want it to go to D9, so D4 to D9, and then hit OK, and it averaged them together. So one way of doing this is, again, you have these values locked in here, like this and this. Let me show you a cool thing about Excel. Let's say that you typed all this in, just like we did. You've got, the cells are all lined up, and you think you're all done, and you look at your data, and you realize, wait a minute, that on my paper actually looks like a 0.36, and I typed 0.35. Man, if it's supposed to be 0.36, better change that so that the cell data matches what I got from the lab. When we hit enter, it actually did do some math in there. We can't see it. Let me undo that so you can see where all the math is hiding. There we go, add some values. So it changes back to 0.36. Let's see, this changed, which then changed that value. This is an average of all of these things, and it kind of cascades through. Once one value is changed, if the formulas are lined up correctly, then they'll all change. So now we know that we have osmium. Let me pause for a second and go look up something. Alright, in a minute we're going to do the molar mass. Going to do some mole calculations. I need to write something down here. This is the molar mass. Okay. Just shift this over here. Alright. So, thanks Toshiba. That was well timed. Well timed. We need to maybe create a graph. Yeah, that's a pretty common thing. So if creating graphs, we might highlight the data. There's lots of things we might do. We may want to organize this. Look how this data here is all out of weird order. It's not largest to smallest. We might highlight the data and come up here where it says data. We could sort it. We might sort it by mass. Right now it's of course sorted by samples. We sort it by mass. Boom. Puts them in order from smallest mass to largest mass, smallest volume to largest volume, and the densities are all over the place right now, which is interesting. We could sort it by densities. Let's try that. Here we go. Or of course, we got all this still highlighted here. We could sort it by samples, which we're going to leave it by samples because that makes the most sense. This is the order in which they were gathered. But let's now graph this data. So I'm going to highlight the mass and the volume. That's what I want to make a graph of. And we almost always make XY scatters, just the dots. Boom. That is a really big graph. Right, still kind of big. Density, unknown metal, I'll take that. I don't know why the font size is so big on this. Let's fix that, maybe bring it down to something that's not crazy. Don't need that. What else do we need on our graph? Ah, yeah, maybe we could, I don't know, add, let's see, layout. I got the graph selected? There we go. So it's chart titles, axis titles. What is this axis? This is the volume. That's the volume. Probably in milliliters. Right? And then this axis is the mass. So there, it's the mass. Probably in grams. There we go. And then we should do maybe a trend line. You right click on it, you can add trend line. That's also an option up here. So it's trend line or add trend line. And there's lots of different options. One I really like is display equation. If you display R value, that can make you feel pretty good about your data. This is kind of a weird value right now. You know what? I have the mass and the volume kind of backwards for what you would usually graph. Let's pause. Let me see if I can figure out how to switch them. So when I made this graph, I was intending on, having a nice slope here, and the slope would be the density, but I messed up. I've got these two values backwards, and one of the key things, this happens all the time, is realizing how to switch them, and I just figured it out. Somewhere here it says select data. Oops, let's click on that and go select data, and we can edit the data right here. And so I'm going to say, these x values, I really wanted the volume on the x-axis. So this needs to actually be this. There you go. And then the y values, I really wanted those to these masses here. And then when I click OK, there we go. And so you can see that the slope is actually equal to our density now. It's pretty cool. And the R value is very close to 1, and if you've taken stats, you know the closer R is to 1, the better your data is considered to be. And again, if you come in here, oh wait, just kidding, that was a 5. My handwriting's so hard to read. You see values will shift as the data is changed. I am not doing a very good job of guessing random values to put in there. My R value is getting worse. And there you go, creating a graph. This graph is now pretty much done. You could copy and paste it into the Word document or whatever you needed to do. I'm just going to move it out of the way. The one last key skill here, maybe we want to know the moles. Moles are equal to mass divided by molar mass. There are two ways to do this. We could have our molar mass typed out a bunch of times. And we could say this is equal to the mass divided by the molar mass. Yay! And there's our moles. And then we could drag down and repeat it a bunch of times. So we wouldn't be learning much in terms of skills right then. So instead, we're going to use the $sign with the letter and the number in there. And this $sign thing kind of locks a value in. Let's delete these. And we want this to be equal to the mass divided by this value. But if we insert a $sign before the H and before the 2, can you see that in there? It's B4 divided by $sign H, $sign 2. It is going to then be locked into place there. When I drag down, it keeps going back to this value. See? It keeps saying $sign H, $sign 2. So the signs kind of lock it onto that one cell and it repeats it over and over and over again. There's a shortcut key with the F8 or something like that. I can't quite remember what that one is. I think it's F5. Anyway, it inserts the $signs for you, but it's not too hard to use the $sign function. Again, key skills, mass, divided by volume, you just type the cells into there. What else could you do? Gosh, you can do lots of things, I guess. It's pretty nice. I could, any other, oh, averaging. We could do some averaging. This data is probably not the best for averaging. Maybe some. We could say, okay, meaning these moles are probably not the best for averaging. We could say, what's the sum? What's the sum of all the masses? It's adding them all up for you. Bam, that's all total mass. And we could do the same thing for that and get the total volume. We could drag down and get the density. It's doing those two values. Great. And I guess we could technically do the same thing here. I don't need to, but could. So Excel has a lot of key nice skills. You type in the equal sign, you hit the values you want. Underneath the functions, you have all sorts of crazy functions. Sum, if, reverse lookups, standard deviation. There are some things like if you can set it up so it will only pull values that are above a certain threshold. So if you only want the values that are above like 5, you can tell it to only grab those values. You can have it color coded if the number gets above or below something too small, but those are all kind of above and beyond what we need. Let's see if there's any other things we could do here. Just a couple other things. Like I was saying, there's lots of different formula options. If you go up here where it says formulas, you can kind of see some recently used things, financial. Some of you might be interested in the trig aspects of things. There's natural log. Ooh, look, there's the natural log. Yeah, who doesn't love the good natural log, right? It's in there. So you could, equals ln and then select a value. Look at that, we've gotten the natural log of something. Again, you type, you hit the parentheses, and you select the value. Close the parentheses, enter. Um, uh, Formatting wise, this is not terribly important, but there is, make things look like a table. Oh, look how pretty this table is now. You could have all sorts of silly things. But really, the calculations aspect is what makes Excel so powerful. I hope this helps. Good luck, and talk to you later.